Hi everyone, today is February 21st, 2019. This is my 10th episode about C++ type function and modern C++ programming. I believe you are more advanced users. You have some experience in C and C++ language if you are watching my video. But I will deal with this concept because I think these are most confusing concept for both C and C++ learners. About constant character pointer reference. I am talking about string literal in C++ or literal string in C++. C++ language is the most difficult language to learn. But if you learn C++ language the right way, then you can understand it and you can be proficient in this programming language. I was trying to explain about std tuple in this session. This is creference.com and it is talking about std tuple. And it gives some sample code like this, but it is not correct way to create a std tuple class. It is very naive method, so that's why I am here to help you understand more advanced concept. After watching this video, please leave your comments if I am wrong or I am correct. To understand C++ language, you have to learn assembler language. Assembler language is a must-have. It's not option. Okay, if you are learning C++ language or C language, you are targeting your career to be real developer, not hobbyist. If you really want to create and understand the computer, then you have to understand assembler language. If you understand the assembler language, you don't need to be proficient at assembler language. As long as you understand how the CPU operates, how to read some basic level of assembler code, that's good enough, for you will never code in assembler language in your lifetime. If you have some minimum experience with assembler language, this session is not necessary because you will understand all these concepts. If you think this session is a little bit helpful to you, I highly recommend you to learn assembler language if you haven't done it yet. I searched YouTube about assembler language. I think this is very good tutorial series. I have nothing to do with this gentleman and he does not know my channel. I highly recommend this gentleman's assembler language series. Also, you can watch this tutorial and there are lots of other good tutorials on YouTube about assembler language. So please learn assembler language. This is my previous session. If you haven't downloaded the source code from our previous session, please click this link and download the source code. When download is complete, show in folder, you can double click it, copy, then paste it to your working folder. Click the folder, copy the folder path, right click your command prompt, properties, paste the folder path in starting field, click OK. Start Visual Studio Code. File, open folder, paste, select folder. Click this button, 09, literal string. Click this button, PCH pch cpp literal cpp. In here include talk play fun type util dot h. In pch cpp include pch h. In literal cpp include pch h. Then we need one more header file, include cstdio. Okay, I will start with this file first in this session, int main. I create a global constant character message name 1 Thomas Kim void test literal string. I created a function constant character pointer name 2 Thomas Kim. Note that this is global literal string local literal string. Now we are displaying the address of this each string like this. Printf address of name 1 %p like this, name 1. Printf address of name 2 %p and name 2. Now we are calling this function like this. Then we print out, we start our command prompt cd 09 literal string cl pch underscore local pch cpp. dir cl at msbc local literal cpp. Address of I fixed like this. Then compile again. Okay. Please note that name 1, address of name 1 is 22C0. Okay, address of name 1. Address of name 2 C2C0. So name 1 and name 2 points to the same memory location. Name 1 and name 2 point to the same memory location. That is name 1 and name2 are the same object. In C and C++ language, literal strings of the same content are merged together and they are not created separately. So Thomas Kim and name1, they are the same thing. Understanding this fact is really important. If you ever have experience in assembler language, you must already know of it. Though the literal string Thomas Kim is in this function test literal string, its memory is not on the stack. Its memory is in the data section of the generated assembler language. Now I create another variable here, constant character, my name, Thomas Kim, printf, address of my name, %p, my name. Now let's build. As you may guess, this address, my name's address, this address are all the same. They are all the same. Let's double check it. They are all the same. 22C0, 22C0, 22C0. These are all the same. Now I will disable this part and create another function, deeper understanding constant character name1 S P O P H I E. This is character array. Constant character name 2. So P. Constant character array pointer name 3. So P. First, examine the byte size of name 1 and name 2. I will create here auto stream talk play fun stream. auto nl stream get console out. Stream byte size of name 1, size of name 1, nl stream byte size of name 2, size of name 2, nl stream byte size of name 3, size of name 3, nl. Note that, okay, I will compile it. It does not give the byte size of the string, literal string. Now let's build. Microsoft compiler we have to call this function copy paste m. I'm using 64-bit. It doesn't give byte size of literal string. It is 8. This is 1 to 6 characters, including null terminating string. In this case, in case of name 1, this is 6 character byte size because null terminator 0 is not included. Terminating 0 is not included. Terminating 0 is included. In this case, terminating 0 is included, but it does not give size of name 3, returns the pointer size, constant character pointer size of names. So this is 8 byte, address is 8 byte. If you want to fix this, then you have to do like this. Stream byte size of name 3 strlen name 3 and like this strlen. Now let's build again. Okay, this is 6 character. In this case, terminating 0 is included in the name 3, but strlen returns byte size not including 0 terminator. So this is 6 means 6 character. Sophie not including terminating 0. In this case, name 2 is array. It is equivalent to this. Equivalent to, you have to specify like this. This is equivalent to 1, 2, 3, 4, 5, 6, 7. So it returns 7. And in this case, it returns byte size. This is array, not null terminating character. Okay? So don't get cheated by this. You need to have correct understanding. In case of 2, in this case, 0 is, this character is included. In this case, name 1, this character terminating null is not included. Now let's try with GNU compiler. All should work. It should work the same. Now we are using standard stream out as std cout name 1 name 1 std and there. Please note that name 1 is not 0 terminated string. It should crash. Okay, now let's double check it. With the Microsoft compiler, this is Microsoft compiler, and Sophie name 1 Sophie is displayed properly like this. Now with the GNU compiler, garbage character 0, some garbage character. It hasn't crashed, but it still does not working properly. GNU compiler is more closer. GNU G++ compiler is more C++ standard compliant or conformant. So this is not correct. Okay, I hope you understand. In case of GNU, this is correct. GNU compiler is behaving correctly. In case of Microsoft, they modified the standard library std cout. Now let's try with the stream name name 1 std and there. So let's compare with Microsoft. We will compile with Microsoft. See, this is from this stream class. std cout is from Microsoft stream class. In case of this string class, it regards this as byte array. This is byte array. Okay. Now let's try with the GNU compiler. In case of GNU compiler std cout, it fails because this is not null terminating character, not null terminating character string. It fails in this case because it regards this as character array. It works properly in both cases. Okay, I hope you understand. And also, this name2 and name3 has significant difference. Name2 is a character array. Name3 is constant character literal string. They are in different scope. Name2 is allocated on the stack of this function. That is, you cannot return the address of name2 because when this block ends, name2 does not exist, whereas name3 still exists. After this block ends, it means we can still return the name3 as pointer because name3 is constant character pointer and is initialized with literal string. The literal string in C and C++ does not reside in stack but in data section. Name2 is a stack variable. Name3 is a name3's memory does not reside on the stack. Understanding this point is very important. Let's try what I mean. We can display address like this. I copied here. Address of name1, address of name2, address of name3. We are checking the address of each name1, name2, name3, like this. Now let's check with the Microsoft compiler. M. Now let's see B0, B8, their address. Okay, they are on the stack. They are on the same address space. Name1, name2, they are on the same address space. They are 8 byte difference. In case of name3, gives totally different address because this is in data stack, data section, totally different place. This really confuses C and C++ beginners. In nutshell, you can return the address of name3, or not the address of name3, character address, character pointer, but you cannot return this character point of name1. But you cannot return name1. Also here, you cannot return name2 because name2 disappears when this block ends. Between name3 and name2, or between name3, name1, there is one more big difference. This name3 reside in data section is protected. Data section is protected from modification. So character pointer name3 0. We are trying to modify the first character of name3, so P to T, like this. std cout name3 std, and there it does not work because data section is protected. Now let's try it. Before we try it, we can copy this part and paste it here. So P here. I modify to 3, 2. Then I can paste it once again. Here, name2, since name2 is on the stack, it is not protected. We can modify this name2, but we cannot modify name3. With GNU compiler, G, name1 displayed, this displayed, name2 top, this name2 is modified, name2 modified, but name3 crashed. In name3 this crashed. Now with Microsoft compiler, name3 Sophie, name3 still Sophie, it's not modified. We modified name, it should be Topi, like this. In case of name2 stack variable, we can modify like Topi. Name3 also should be Topi, but it's not modified, it is still Sophie. So data section is protected from modification. Can you find this information from C++ book or C language book? I highly doubt. If you have understanding about assembler language, I don't need to explain it. You can just know. So please learn assembler language. Thank you for watching.